I'm going to finish the rest of the tangent-cotangent practice. So for number 3, I skipped it because I did not know what the equation was. It didn't print. So now that I have it, I can answer the question. So I'm going to make a quick sketch of this graph. We know it as a vertical shift down 1. No horizontal shift, so it's going to start right here on the y-axis. We know it's a cotangent graph, so at its starting point, we're going to have an asymptote. We also know that b is 4, so that means if we do pi over 4, we will get the period, which is kind of annoying. This is pi over 2, which means pi over 4 is right here. So that's where our next asymptote would be. And the next pi over 4 will be right here. I don't think I'm going to draw the rest of this graph. I think that's going to be enough for the asymptotes. I know that, and I'll just sketch this, that the cotangent graph are going to have points in between, and you should know that it goes downwards. So like, whee! This is awful, right? So that's 2 periods of that function. So let's answer the questions we should be able to answer. The domain is all real numbers except, well, it's going to exclude all the asymptotes. The first one's at 0, and then they appear to be pi over 4 apart. So plus pi 4, plus pi over 4k. The range is always all real numbers for these. The asymptotes, we said, were the same as the exclusions from the domain. And I'm going to drop the 0 because it doesn't matter. The period, we already said, is pi over 4. The vertical shift was down 1. And the midline was at y equals -1. Now let's go forward and let's do the first problem on this page. So we're supposed to write a tangent function, so that's easy, tangent. It has to have a period of 3, and so you need to know that pi over b equals the period, or that pi over the period equals b. So since we know the period is 3, we know our b value is pi over 3. It's supposed to be reflected over the x-axis, so that should be negative. We're going to need an x here, and it needs to be shifted down by 2. That's it. For 2, we're going to do the same thing. We need a cotangent function. We know the period is 4 pi, so that means pi over 4 pi has to equal b. That's really a 1 there. Those cancel. Gives us a b value of 1/4. It has a horizontal shift of pi over 4 to the right, so I have x minus pi over 4. It's shifted up by 1, and that would be a perfectly good function. Notice for both of these I did not put an a value in because I didn't know what they were, so that's okay. You could put any number here that you wanted. So 1's the easiest. All right, so what we're going to do next is we're going to write equations for the given graphs. And notice here, number 7 is going to be a secant or cosecant graph because notice, not s's, they're u's. All right, so number 3, I always like to put in the asymptotes to give me some perspective. And you have to pick a starting spot. So I think a nice starting spot would be right here, because that appears to be on the midline, and it also looks to me like it's a tangent graph, because tangent goes upward and starts on the midline. So my first guess is I'm going to write a tangent function. Okay. Now we need to know what the period is. If you count between these two asymptotes, that distance is 2 pi. Or if you count from this point to that point, it's also 2 pi. And we know the formula says that pi over the period equals b, so that will give us a b value of 1/2. From my point of selection, I have no horizontal shift. There does not appear to be a vertical shift. The only thing we could also figure out is what the a value is. And it looks to me like this graph went up 1 and then halfway to the asymptote, so I think it's 1. So that would be perfect for the first equation. Now for a second equation, I want a cotangent. So I'm going to pick a different starting point, and it has to be on an asymptote. So that's going to be my starting spot. So now I've got cotangent. It's still going to have the same b value. I have a horizontal shift of pi to the left, and still no vertical shift. The coefficients would still be 1, but this time it's going to be a negative cotangent, because cotangent usually goes downward, and this graph is going upward. It's increasing. So that's something that you should always notice. If you have to write a tangent and a cotangent equation for a graph, one of them has to be negative. Let's do the same thing for number 4. So I'm going to draw in some asymptotes here. So there's an asymptote right about there. And there's one right about there. Once again, I think this is a very convenient starting point. That looks to me like an upside down tangent graph. So that's what I'm going to use. Y equals upside down tangent. It appears that there might be a period change here. So if you count from this point to that point, that is a distance of pi over 2. So we know the period is pi over 2, and we know that b is always going to be given by the period, divided by the period, which equals pi times 2 over pi, which equals 2 pi over pi, which equals 2. So we're going to have a b value of 2. Then I don't think there's a horizontal shift. I don't think there's a vertical shift. And the only thing we have to decide is what do we think this number is here. It looks to me like if you go halfway towards the asymptote, you go down about 1. So that's probably 1. So let's do the same thing for cotangent. I'm going to pick a cotangent starting spot, which is on an asymptote. It's going to be a positive cotangent because it's going downward. The b value is the same. It looks to me like that is a shift of pi over 4 to the left. And there's no vertical shift. And that would be our cotangent equation. For 5, the same idea. The tricky thing we first need to establish is it looks like there's a vertical shift of down 2, right about there. That's where there's a bend in the graph. And then we've got asymptotes, it looks like right around here and here. So I'm going to pick a starting point, and my first starting point is going to be right here. So that looks to me like I've made a cotangent graph, because cotangent slopes downward, and it starts on an asymptote. So that's great, cotangent. The period of this graph appears to be pi, so our b value is 1. Great. So it's cotangent x. I started on the y-axis, so there's no horizontal shift. The vertical shift is down 2, though. And if we look at the graph, it looks like these tangents are going down by 1 to get to the point halfway to the asymptote. So that would be cotangent. If I want a tangent graph, I need to pick a spot that is on the midline. So like right there, at pi over 2. So this is a negative tangent graph because it's going down. It is shifted pi over 2 to the left, and it has a vertical shift of down 2. Let's do the same thing for number 6. Once again, I'm going to draw in some asymptotes. And then I'm going to pick a starting spot. I'm going to pick this point right here, which would make it normally a cotangent graph. But it's a negative cotangent graph because it's going upward. Cotangent usually goes downward. And let me make this clear, I pick cotangent because it started on an asymptote. The period here appears to be pi, that's the distance between the asymptotes, so I don't have to put in a b value other than 1. There's no horizontal shift, and there's no vertical shift. And the number in front of here probably is 1 again, because if you look up, it goes about up 1, halfway to the asymptote. For a lot of the writing equations 1, the a value will be 1. If I want to look at this as a tangent graph, I'm going to start right here. So that's going to be a positive tangent graph because it's going upward. The only difference is going to be it has a horizontal shift of pi over 2 to the right. All right, danger, danger. This is a secant-cosecant problem that they're used. So I'm going to go ahead and make this graph that's in between. That looks to me like it might be either sine or cosine, and that appears to be where the midline is. So we once again have to decide where we're starting from. I think here's a pretty good spot. And from the looks of things, if I read this right, that looks like 1 full cycle at 2 pi. Great, we don't have a period change. The period is 2 pi. Remember, for secant and cosecant, the default period is 2 pi. So the first equation I would want to write, if I'm starting from here, looks like a sine curve. So that means I'm going to write cosecant, because that's the reciprocal of sine. The amplitude here is 2, so I'm going to have a 2 in front. And then I did not have a horizontal shift, and I did not have a period change, so it's just parentheses x, but it is down 1. I'm going to do the same thing if I start from here. So now that's a cosine graph, so it's 2 secant of x, but I have a phase shift of pi over 2 to the right with still a vertical shift of 1. All right, let's shift gears again. We'll go to 8. Here we've got a tangent or cotangent graph again. Appears to me that there's a vertical shift. That appears to be where the midline is. And then, oh my. So if I'm reading this right, this point and this point are pi over 2 apart, which means that the asymptotes are at pi over 4 and negative pi over 4. So let's see if we can do this. If I start from here, that is starting on the midline. So I'm saying this is a tangent graph. It's a positive tangent graph because it's going upward, and it looks like the distance it goes downward to get halfway the asymptote is 1, so I'll leave that as 1. Because the period appears to be pi over 2, the distance between this point and that point, I'm going to find that the b value is 2. There is no horizontal shift, but there is a vertical shift of up 3. If I want the cotangent version, I'm going to need to start on an asymptote. It'll have to be a negative cotangent because it's going upward, and cotangent usually goes downward. The b value is still 2, and here I'm going to do x plus pi over 4 because that's the horizontal shift to the left. Once again, a vertical shift of up 3.